So now we're going to take a look at the next level of these piecewise defined linear functions, where we have more than just a line. We have a line and a piecewise defined point. So our job is to recognize there's two things going on. There's two rules happening. First, there is a line, and we've got to find the equation of this line. Now, because this touches the y-axis, I'm going to go with the simple of just using y equals mx plus b form, our most basic version of a line with y already isolated. And all I have to do is identify the y-intercept here, which is -8. That's my b value. And then I have to count rise over run to get my slope. Now notice it's a positive slope line. It's going up from left to right. So I'm just going to count rise and run here, up to right 1. So the slope is 2 over 1, which is 2. So 2x minus 8 is the equation of my line. Now that line is everywhere except one spot. Notice there's an arrow to the right, there's an arrow to the left. This line would be the whole function except for that one piece. So here's what that means. We use that line definition everywhere except when x is 4. So what we do down in our function definition, we go ahead and write 2x minus 8. That's my line, my linear function component. And we use that rule for everywhere except one spot. So to say everywhere except one spot, you just say x not equal to 4. So what it means is everywhere else except when x is 4, this is the rule. And then down here, we just have to define what then does the graph tell us to do when x is 4. Well, it might be nothing. If there was just an open dot right there, that would be it. But they went ahead and redefined, there's a height here of 4. There's a dot here of 4, 4. So what I want to do is define the function so that the output will be 4. And so what I do is I type in a 4 output for x equals 4. So what that'll do for me is if I input 4, I don't use the top rule. I don't use this rule here. I would jump down here, and when it says when x equals 4, I would jump in and have an answer of 4. Everywhere else, any other x value, I would use the equation of this line, and it would put me on a dot somewhere on this solid line. That's how we do it when you have individual pieces. We'll look at more in the next example. So here in our second example, we've got 3 components, 3 pieces to this function. So the first thing I want to do is recognize that there's 3 rules that need to be present. So what I need to do is this generator will come with 2 lines built in, so I need to add a rule because I'm going to have 3. And so I need to recognize that there's going to be a left facing rule, a middle dot there, and then there's going to be a right facing rule. So there's going to be 3 components, and that's working out on a number line here where basically everything hinges. Well, let me do my number line over here on right underneath the graph. Everything hinges here at 1. So that means I'm going to have x less than 1, -1. I'm going to have -1, and then I'm going to have x bigger than -1 are going to be my 3 rules that I'm going to type in there in a moment. But now let's focus on what these rules will be. Well, this is a linear function. So there's 2 ways I could find that. I can use point slope form or I can use slope-intercept form. Because we're so close to touching the y-axis, I can just see, I can feel the y-intercept would be 3 if I had extended that line. I'm just going to go ahead and use my point slope or my slope-intercept form this time to just get that answer very quickly. So I can see that had I continued the slope, which the slope is up 2 over 1, up 2 over 1, if I had continued up 2 over 1, I would touch the y-axis at 3. So for this line, its definition would be y equals, the slope is 2x plus 3. So what I do in that first box is I type in 2x plus 3. Because it's right there almost touching the y-axis. If it was far away, I'd use the point slope form I had in previous examples, but here, let's keep it simple. Now, that rule will be used whenever x is less than -1. because there's an open dot, I don't use this definition at -1, just less than. So right here, make sure that you don't have a less than or equal to, just less than. Now, let's continue in order. I'm going to talk about what happens when we're actually at -1. When we're actually at -1, I'm supposed to be at this y height here of -5. So when x equals -1, I go right down there and have that output of -5. So to write that, I say the output will be 5, -5 I meant to write, or x equals -1. So now what I just defined is that when I put in a value really close to -1, I'm using this upper rule. When I go ahead and type in a value of -1, I'm now using this bottom rule, and now I'm going to define everything to the right of -1 to be on this last line. This last line I need to redefine or define using slope-intercept form. Would be the simplest way through it because it does indeed touch the y-axis here at 0. So the b value is 0. So it's going to be just based on my slope. My slope goes, first of all, it's negative because it's going down. So make sure you do get a negative slope result. Find two dots. Here's one dot, goes down, and then over to this dot. That's down 1, 2, 3, right 1. So that's a slope of -3. So this equation is going to be -3x plus 0, if you will, but the 0 doesn't matter. So just y equals -3x is the equation that goes in that last box. So we type that in down here. So now we're going to go ahead and take a look at writing that in the box down below. And so we type in -3x, and then we use that definition for everything bigger than -1. Those three pieces make up this piecewise defined function graph as the function rule. All right, on this one, we have only two pieces. There is a horizontal line down here. Anytime you have a horizontal line, it's defined to be y equals whatever value it would cross at the y axis if it crossed it, and this one does cross at -6. So -6 is the constant definition of that horizontal line. Then we see that there's a random dot because this line is not defined when x, or not the definition for when x is -2. So there's two pieces, and so what I want to do down here is define the height to be -6 for everything except that one spot. So the way that I do that is I just focus on, well, that x value is -2. So to have it be everywhere else, I just write x can't equal -2. And what that does is it means that this function rule is -6 everywhere except -2. And now I need to define, well, what does happen if x equals -2? Well, when x is -2, we see that the function is defined up here at y height of 3. So I go ahead and type 3. So there's two constant values that make up this definition, but one, because the rule defines it for a length of domain, makes a line. This definition, this 3, just makes a singular point because it is only defined for one x value for that y output. And now for our most complicated of the 4 that we've done here, we've got a linear, single coordinate, and a constant function. So we're going to do our intervals systematically from left to right. Essentially, on the number line here, we have -2 is an issue, so everything less than -2 is going to be one definition. That's going to be our leftmost definition here. We're going to have a middle definition at -2. So at -2, we have an actual output, singleton. And then we have an interval that goes from -2 to 1. So from -2 to 1, we're going to write a -2 is less than an x, which is less than or equal to 1. So 3 rules here. We only have 2 set up for us, so we're going to go ahead and add a rule. And we have our leftmost rule. We're going to have that middle rule with this negative. So this is be the leftmost, the middle, and then we have a rightmost rule. And I'm just going to put them in that order, descending down the list. So let's begin with the line. The linear function, we have a slope of 1. So notice it's going up if you read it from left to right. Don't confuse it going down to left. It's going up from left to right. So that's a positive m, positive 1 over 1. So m equals 1 for that slope. And because I'm far enough away from the y-axis, I mean, you could see that it's going to touch at 1. But just for review, I'm going to use the point slope form. Y minus y1 equals m times x minus x1. So I just need a point and a slope. My slope is 1, so we have m is 1. I write x minus y minus, and everything's ready for me to just fill in a y and an x to have that slope set up. So I need any coordinate on here like this one, -7, -6. So -7, -6. I go ahead and call this my x1, my y1. It's my one coordinate I picked. Any of them would have sufficed. So I put -6 here for the y and -7 here for the x. And all I have to do is move the 6 to the right-hand side. I'm going to change both these signs because it's minus, 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 minus. So I subtract the 6 to the other side. And the equation of that line will be y equals 1x. You don't have to put the 1x, but I'm going to. 1x plus 7 minus 6. Now, again, I could have done it much simpler just using point slope form and just recognizing the b value as 1. So I could have written y equals 1m, or 1x, I meant to say. M is 1. X plus 1, which is what this is equivalent to. Either one will work in the box, x plus 1 or x plus 6 minus 6, which is still x plus 1. So that's the equation in that first box. So let's put that in there. So just because I did it the long way, I'm going to write it the long way, x plus 6, or sorry, x plus 7, and then plus 6 on the outside, minus 6 on the outside. And I use that rule for everything left of -2. So left being less than -2. So now when x is -2, it kicks out a y height, a singular dot of -6 right here. So I have -6 is my output when x equals -2 is the input. Finally, I have an interval of a constant y height. So this y height here of 5, y equals 5, I put 5 as the output. That's the equation, 5. And I do that on the interval from, on its domain, from -2 to 1. That's the domain that you use that interval, that output for. So I go ahead and put in here -2 is less than x, which is less than or equal to 1. And again, I use the less than not equal to on the first one because it's an open dot, and the less than and equal to or equal to the 1 because it's a solid dot at the end of that interval. And this should be your 3 function piece definition for this graph.